Good day. This is Kim McCleary. I'm President and CEO of the CFIDS Association of America. It's November 18th, and we're grateful for everyone who's joined us today for our 18th webinar of the 2010 series. Our topic today is minimizing relapses, pacing yourself through the holidays. And as we look ahead to Thanksgiving next week and many different holiday festivities over the next few weeks, I think we timed this topic pretty well based on the feedback we got through the registration through the registration process. Before I introduce our two guests for today, I'm just going to take a moment and go through some housekeeping tips. We know that about 60% of our participants today have taken part in another of our webinars, so we won't spend too much time on this, but I did just want to give an orientation for those who are new to the webinar software. As I indicated, this is our 18th webinar, so we've had a bit of practice, but each one of these tends to be new, and I know that our two presenters are taking part in their first webinar as presenters, so just bear with us. We're all three in different locations. So Dr. Campbell is out on the West Coast, Dr. Cook is at his place in Madison, Wisconsin, and I'm in Charlotte, North Carolina. So we can't see one another, we can't see you, you can't see us, and so we're all sort of having our own individual experience of this while we're all together collectively through the magic of GoToWebinar. We have served more than 20,000 viewers through our webinars, and I think that's just tremendous. And as I was commenting to Dr. Cook and Dr. Campbell before we began, it's nice that nobody has to get on a plane or travel across town or go through body scanners to attend these. So we thank you all for making this such a successful series. When we sent out our registration materials, we gave the folks who registered an opportunity to give us some information about their experience on this particular topic of post-holiday crash. And 92% of more than 300 registrants told us that they experience a crash following the holidays or special events. And for some, this crash can last more than a month. You know, that's just a significant impact. So as we look ahead toward the holidays, we're happy to present both a bit of practical information about how to avoid or minimize relapses, as well as some scientific information about why your body does this to you. We also shared the other questions that were submitted with registration with Dr. Campbell and Dr. Cook to help them prepare for the presentations. And we'll take questions as the presentations unfold. So using your control panel, there is a small chat box at the bottom of the panel on the right-hand side of your screen where you can type questions. Those actually come all to me, and then we'll have kind of a moderated panel discussion at the end of the two presentations. This program is being recorded, and the recording and the slides will be posted on our website within a day or two, and you'll get a follow-up email with information about where to find those tools. We'll also post it on our Facebook page. If you visit our Facebook page, you'll be able to find the URLs for both the recording and the slides. The speakers today are not able to address individual questions about symptom, therapy, treatment. Neither of them is an MD, and even when we do have an MD as a speaker, this format just does not lend itself well to addressing questions of that kind of a personal nature. So we'll just let you know ahead of time that we won't be able to address those today. Now it's my pleasure to introduce Dr. Bruce Campbell. Dr. Campbell is a graduate of Stanford University and the University of California, but I think even more than his academic training, what makes him an expert in this topic area is the fact that he himself is a recovered CFS patient who has used these strategies personally to improve function, quality of life, and be able to live at a more predictable activity level than what many people experience as a result of CFS. In developing this program, he founded the CFIDS and Fibromyalgia Self-Help program, and we know that many of you who've registered for today's program have taken part in one or more of his online self-management courses, and they've been a tremendous help to many people. I've provided the URL for his site there, and there's an excellent article library of tremendous resources there, as well as a store where you can purchase more detailed information about some of these topics that he's going to move through today. Dr. Campbell's also been a consultant to more than a dozen research projects at the Stanford Medical School and has written many books, articles, and course curricula. And just in October, I believe, he and Dr. Charles Lapp at the Hunter Hopkins Center launched a new website called treatcfsfm.org, where you can find even more information about self-management of CFS and fibromyalgia. So with that, I'm going to transfer the controls over to Dr. Campbell, and hopefully we will be successful in doing this. If the audience will just bear with us for a moment while we switch controls. Bruce, take it away.
Thank you very much, Kim. I hope you can all see the first slide up now.
Yes, I think it's showing just fine.
Very good. I want to thank the CFIDS Association for asking me to participate in the seminar. And I've noticed the same thing that Kim did, that a very high percentage of people who registered said that they have experienced crashes from the holidays or other similar events. And so this is a timely topic, and I hope you hear things today that you can put to good use. I'm going to follow in my presentation the same approach that Dr. Lapp did when he spoke about the stepwise approach a few months ago in an earlier webinar. I've prepared a set of my slides that include my notes that the CFIDS Association will be posting at their website. So I'd say the same thing to you that he did, that you can sit back and listen to what I'm saying. You don't have to worry about taking notes. It's the notes will be provided to you in a day or two through the association. Okay, now, should have the second slide up. And I'm going to begin by saying that we're going to look at pacing in terms of what happens when you don't pace. And our attention was drawn to this earlier this year when the CFIDS Association, specifically Jenny Spatilla, wrote a 4-part series on post-exertional malaise that's posted on the association website.
Bruce, can I ask you just to speak up as loudly as you can? Whoop.
Okay, is that any better?
I'm getting some comments from people that they're just having a harder time hearing you than they are me. So just whatever you can do to maximize the volume on your end.
Okay, I'll see what I can do.
Thank you. Sorry about the interruption.
No problem. So Jenny Spatilla's series on post-exertional malaise talked about how pacing is a way of avoiding post-exertional malaise, or looked at the other way around, that post-exertional malaise is what happens when you don't pace. I think the primary fact that came through that series to me was that post-exertional malaise is out of proportion to the overexertion that somebody experiences. And let me explain that by using a concept from Dr. Lapp, which is energy dollars. He talks about how people get a certain number of energy dollars every day that they can use, they can spend to go through their day. And a healthy person might get 100 energy dollars a day, but an average person with chronic fatigue syndrome gets about $25 a day. In our experience, having had several thousand people in our program, and each of them telling us at the point they enter what percentage of normal they think they're functioning at, the average has turned out to be about 25%, with almost everybody between about 15% and 35%. So I'll just take 25 as the average in my comments going forward. So if somebody overdoes it a little bit and they spend 30 energy dollars, that puts them $5 in the hole. But there's something special about post-exertional malaise. Maybe Dane will talk about this in his talk, where you get, in effect, an overdraft fee, a post-exertional malaise overdraft fee. And that means that in addition to being $5 in the hole just by overdoing, you get $30 or more in post-exertional malaise fee for a total of $35. Let me give you a couple of examples from people in our program. There's one person named John who functions probably about 45% of normal, so he's much better than average. And he sent a message to one of our groups recently saying that he'd been doing an hour a day of gardening in addition to his other activities, and that had worked out very well for him. And one day he decided he'd try 2 hours of gardening instead of 1. And he ended up spending the rest of that day in bed, and he had a 10-day relapse. So the 1 extra hour of work created a relapse that lasted a week and a half, so out of proportion. Another person is Rose. She's on the other end of the extreme. She's a bed-bound patient in Australia, and she had said that she's told her groups that when she has house guests, which she does typically every year, she will experience a relapse after they leave that generally lasts her 4, 5, or 6 months. So in both cases, there's the key fact for me about post-exertion malaise is that the effects are way out of proportion to the event.
Bruce, if I could stop you once more, I'm sorry. There seems to be some interference, maybe a cord on the microphone or something that's interfering with the sound.
Okay. Well, I'll see if I can be more still, and that will help.
Okay. It's like a waffling noise behind your speech. Sorry about that.
Okay. Well, I'll try to hold my body still. So where does your energy go? How do you spend your energy dollars? I think there are at least 6 different ways that energy dollars get spent. The first is, and probably the most obvious, is physical activity. The things you do around your house, your outings, etc., all use up some of your energy dollars. A second category is mental activity. That would be things like time you spend on the computer, reading, other activities that require concentration. A third area is social activity, and that would involve the time you spend with others, either directly face-to-face, person-to-person, or over the phone, or even via email. A fourth category is sensory limits, and that means that things like sensitivity to noise and light, sensitivity to different kinds of foods, a variety of things that fit into the category of sense experience. The fifth one is emotions. Emotions can be a big energy drain. For example, if you feel frustrated because you have so few energy dollars to spend, you'll lose a few energy dollars just on the sense of frustration. The same thing with anxiety and worry, that those are drains on your energy. So anything you can do that will reduce your sense of frustration or reduce your the amount of worry that you have will work in your favor, because that will free energy for more productive uses. And then lastly, stress. I would say that if pacing is probably the best thing you can do for yourself, managing stress would be the second most important. We're going to look at how to reduce crashes for the holidays by looking at the holidays as an example of a special event. And for us, a special event is anything that's non-routine. It includes the holidays, travel, house guests, remodeling, moving. For somebody who's very limited, it might also include things like just going out to dinner or going to a doctor's appointment. There are two characteristics that make special events dangerous. One is that because they're not routine envelopes, they shrink your energy envelope. You'll have somewhat less energy available than you would for normal day-to-day life. But at the same time, you may feel pressured either within yourself or by other people to do more than you usually would do. So that gives you a challenge. How can you both enjoy an event and avoid a relapse? And what we found is that special events can be handled if you will follow three or use three strategies. The first is to get more rest than usual, and that's resting more than usual before an event, taking extra rest during an event, and resting also as much as you need after an event. So the first strategy is increased rest. The second is to plan an event in great detail, keeping in mind what your limits are. So if you're functioning at 25% of normal, you'd be able to do approximately 25% as much as the average person, probably discounted slightly because the special event will reduce your envelope in some way. And then the third principle is to involve others. That is, discuss what you're planning to do and get other people to agree with it and participate in the event in a way that's consistent with honoring your limits. Let me give you an example by returning to Rose, the bedbound patient who was knocked out by family visits. She was taking our pacing course a couple of years ago, right at the time a family visit was scheduled, and so she decided to use these three principles to see if that would have any effect on her relapse. And so she did several things. First of all, before the event, she took extra rest. So she added maybe another hour or two a day of rest from a week or so before the event up to the event. And then secondly, she thought about how much she could do without endangering herself, and decided that she would have one day of socializing and then one day of rest, and alternate those two through the week-long visit. And then thirdly, she talked she talked with one of the visitors, which was her stepdaughter, and explained her plan to the stepdaughter, who in turn explained it to the granddaughter. So she involved others. During the week that the daughter and the granddaughter were there, she honored her plan so that she had a day of socializing followed by a day of rest. And then after the event was over, after the house guests had left, she spent about 2 days resting and then went back to normal. So by using these three strategies of extra rest, planning, and involving others, she was able to turn a situation which previously had led to 4, 5, 6 month relapse into a situation where she just had 2 days of rest and then immediately could go back to her normal life. So let me say something more about the three principles of how to handle special events. The first is rest. You probably know of rest in one type, and that is the rest that you do to recover from a relapse. And in our program, we call that recuperative rest. But there's a second way that you can use rest, and that is in the way that Rose used it to prevent a relapse, and we call that preemptive rest. So if you can rest before falling over the edge of the cliff, you're probably going to be better off than if you fall over the cliff and then have to take a lot of rest in order to get back to normal. Now, by rest, what I mean is lying down with your eyes closed in a quiet place. I would say that taking one or two or three preemptive rests daily is probably the most common strategy that people going through our program use, and it's something that almost always brings immediate benefits, and it's something that I would strongly recommend. Let me tell you about another incident from somebody else in our program, and that relates to a preemptive rest. And it's about somebody who was cooking a batch of chili, and near the end of the process found that he was very, very tired and weak. And his first thought was, well, there's only about another 10 minutes left of this, so I will just go ahead and finish it off, finish cooking the chili. And then he remembered that in previous situations like that, he had ended up needing 2 or 3 hours of rest to recover from finishing off the cooking. So what he did was to turn off the heat under the chili and went and had a rest for 15 minutes, felt good when he got up, went back, finished the chili, and went on with his day. So taking the 15 minutes of rest enabled him to avoid the 2 or 3 hour rest that he probably would have experienced if he'd continued on without that break. Okay, the second principle that I gave you was planning. First was taking extra rest, and the second is detailed planning. So as applied to the holidays, let's go through this in several steps. First, you can list all of the activities that you might do during the holidays, and that includes shopping, cooking, baking, decorating, mailing cards, attending parties, attending religious services, entertaining, etc. Everything you can think of. And then make a time estimate on what would be involved in each one. So for example, how long does it take to buy the cards, buy the stamps, put messages in the cards, address the envelopes, add the stamps, etc. And then once you've got your time, you've got your list of activities and the time involved, then prioritize from the things that are most important to you to the things that are least important. And then thirdly, define your limits, and that means how many hours a day can you be active, and of those hours, how many are available to use for special activities, out of the ordinary activities. And then compare the amount of time that you have available to the amount of time that would be needed for all of the activities that you've listed for the holiday period. And if what you want to do is greater than what you can do, then deal with those using the 4 principles of delegating, simplifying, substituting, and eliminating. Delegating means finding somebody else to do a task. For example, send somebody else to do some of the shopping, or have other people do the decorating, or change the way that you handle meals so that either you get more help with the meals or have holiday meals catered, or go out to eat, or eat at somebody else's house, etc. Substitute is something that we call sometimes called pigs at a trough. If there are a certain number of of pigs that are trying to get in to eat at a trough, and limited space. The only way that a new pig can get in is by forcing one of the other ones out. So if you have, for example, a limit of 3 activities a week that you can do without creating a relapse, and you want to do something special like go to a party, then one way to avoid a relapse is to postpone doing something else, so that you're substituting the activity for something that you would otherwise do. And then the last strategy is to eliminate activities. You may find that there's just no way that you can do everything you want, and the final category then is to eliminate. Another thing that I'd recommend you do as you're anticipating the holidays is to come up with a plan B. That is, come up with an understanding of what you'll do if, when you get into the holidays, you find that you're over your limits. The two things that most people do, I think, in those situations is, one, give themselves more time for rest, and eliminate some activities that they had hoped to do. Pacing involves changing what you do, but it also involves changing how you think. And I'd like to talk for a minute or two about mental adjustments and other things in the area of how you think about your situation. We have somebody in our class this fall named Colin, and he was talking in the group one week about how he had often been criticizing himself for not being as productive as the average person, or being as productive as he used to be before he got sick. And he said that he then somehow came across a description of koala bears, and that they were described as spending 16 to 18 hours a day in a motionless stupor. And he said, that's me. That's a good description of how I live. And I thought that was a clever and cute way of making an important point, which is that we tend to carry in our minds some expectations for ourselves and what we can do, and those are often phrased in terms of comparisons with other people. So if he's comparing himself to a healthy person or the person he was before he got sick, he's definitely going to excuse me, drinking a little bit of water there, is going to be coming up short. So what he's saying is that in order to live better with myself, I need to come up with a standard that's appropriate to my current situation, not and not make a comparison to other people or to myself before I got sick. Another kind of mental adjustment is changing the things that we say to ourselves silently all the time. We had and that's called self-talk. We had a woman in our program a year or two ago who said that when she got sick, she realized that she was carrying around in her mind the idea that, or the little phrase, I will always work at something until I finish it. And she observed that was leading her to experience a lot of relapses because she was not paying attention to the signals from her body. So she retrained herself to say, instead of I work at things until they're finished, to say I rest when I feel tired. And that had enabled her to avoid a lot of relapses. Another person in our program said that when she first started doing preemptive resting, she heard a voice in her head that says, you're weak if you need to rest. And she said over time that she was gradually able to change that to say, Rest gives me quality time with my husband and grandchildren. So she changed the way she was thinking about rest to give it a positive connotation, think about it in terms of the benefits it was bringing her. The third principle that I gave you for handling special events was involving others and discussing with others. And this often involves having to educate other people about CFS and about your limits. One person in our program made use of the brochure from the CFIDS Association called For Those Who Care, which is designed for family and friends. And one year when she had a birthday, she got a number of copies of this brochure from the CFIDS Association, and she gave one copy to her husband and copies to each of her 3 adult children, and said, for my birthday this year, I'd like you to read this brochure and then for us to have a conversation about it. And even she said that the process that she went through ended up taking about a year, but at the end of that time, both her husband and her children were on board with her in understanding what CFS was like and the kind of adjustments that she was making and the kind of adjustments that they would have to make, and so that they could all live well together. Another element of working well with others is assertiveness. You have to not only know what your limits are, but be able to explain them to other people in a way that they buy into it. And a woman in our program gave an example of this. She said that she had, for some period of time, told people about this, how serious CFS is, but whenever they asked her to do something, she went ahead and did it. And she said it took her a while, but she finally recognized that she was saying one thing, but what she was communicating to other people was, you can make the same level of demands on me now that you did before I was sick. So she went through a process of trying to make a consistency between her words and her actions, so that she would talk about her limits and then say, because I have these limits, I can't do everything that I used to do. Lastly, I'd like to talk about another way of avoiding relapses, which is using devices. One device is the computer, and I'm sure that's something that a lot of you people already use as a way of doing shopping, for example. And another device that is commonly used by people in our program is scooters that are available in grocery and other stores. We had one person in our program say that she used to have to lie down for 2 to 3 hours after getting back from the grocery store, and then she started using the scooter in the store and found that she didn't need to rest. So for every time that she used to go to the grocery store and have to lie down for several hours afterwards, she gained back more time that she could use for productive activity. I want to move toward closing by talking about the benefits of pacing. A big one that we've discussed so far is reduction of suffering, that you spend less time with post-exertional malaise. Another part of, another benefit of pacing is greater productivity. Some people think that because pacing involves more resting, which it does, that's a preemptive rest that I was mentioning earlier, that it leads you to be less productive than you would be otherwise. But people in our program have found that it's just the opposite, that if they are pacing themselves and observing their limits, staying within their limits, they have much less post-exertional malaise, and given the fact that post-exertional malaise is out of proportion to the mistakes that we make, that they can get a lot more done. Another element is predictability, something that Kim mentioned in the introduction. If you're living within your limits, you can have a lot more confidence that you can make commitments and you will be able to honor them. So having a much more stable life is another benefit of pacing. Lower symptoms goes along with less post-exertional malaise. Fifth, people who are pacing in a consistent fashion have a much stronger sense of that they're in control of their life, and if you're pacing on a consistent basis, it makes possible an expansion of your activity level. And finally, pacing doesn't cost anything. We hear that over and over again, that people say, here I chased a cure for many years and spent a lot of money, and then it turned out that I had a lot of power in my own hands, and when I began to use it by pacing myself, I found that my life had improved greatly. If you'd like to follow up on the things that I've talked about in the last few minutes, as Kim mentioned, there are lots of resources on our program website and also on the new website that Dr. Lapp and I developed. I've listed a few on the last slide that come from our program website. We have one section that is dealing with the energy envelope and pacing. If you want to get an overview of pacing in one article, the first one listed there is a good place to begin. That is republished. It was originally published in the CFIDS Chronicle. If you'd like a little bit deeper dive, there's an 8-part series on pacing. If you'd like to hear or read stories about personal accounts of people who've used pacing, success stories, the logs, forms, and worksheet section has a rating scale so you can figure out what % of normal you are, and also many other forms, and also that you'll find books there. So Kim, I think that's it. Let me see if I can figure out how to switch the controls back to you.
Great, Bruce, thank you. And I know that a lot of that information people were writing to me sounded so familiar. The case studies that you provided and the specificity of those, I think, was really helpful to many people based on the comments that came in. I know something that was not helpful was the audio problems where we seem to be having, and hopefully those will resolve. And often the problems we have during the program don't show up on the recording, gratefully. So if you weren't able to hang in there for parts of that due to the interference, take a look at the recording, and hopefully you'll be able to pick up anything that you might have missed. But that was great information, Bruce, and many questions came in, so look forward to sharing some of the audience's questions with you, and as soon as we hear from Dane about the more technical aspects of the characteristics of CFS and the experiences that people have. So now it's my privilege to introduce Dr. Dane Cook. And we had some people who thought we were having Dane Cook, the comic, give our webinar today. So, and Dane tells me he sometimes gets hotel upgrades because they think he's coming in to give a stand-up show rather than a scientific presentation. But maybe he'll be as entertaining as he is informative in his program today. Dr. Cook is the assistant professor of kinesiology at University of Wisconsin-Madison, and he is a graduate of Arizona State University and the University of Georgia, and has also spent some time early in his career training with Dr. Gudrun Lang and Dr. Benjamin Nadelson at the University of Medicine and Dentistry in New Jersey, and that's where he became, I believe, where he became interested in CFS and fibromyalgia for the first time. And now his research focuses on pain, fatigue, and effort, and exercise and neuroimaging, and he's doing some fascinating work with his group at UW. He is the Young Investigator Award winner from the IACFS/ME from 2003, and has continued to distinguish himself in the field of research over the years, and currently serves on the Department of Health and Human Services CFS Advisory Committee. I'm going to stop there for 1 second. Bruce, could you mute your mic? Maybe that will help with some of the interference. If you just press the button on the control panel with the little microphone symbol, maybe we can do something about the rattling. Okay, that seems to have gone away. Thank you. Last but not least, Dr. Cook is one of the association's grantees under our research program. He is working with Dr. Sanjay Shukla at Marshfield Clinic in Wisconsin on a project studying the microbiome after exercise. So all of the organisms that live in our body and perform certain good and bad functions, and those have not really been studied in CFS and many other diseases. It's kind of a new area of research, and he's going to describe that at the very end of his presentation. So I will turn the presentation tools over to Dane. Here they come, Dane. And then thank you for being with us today. We look forward to hearing.
Well, I'd like to thank CFIDS for inviting me. I'd like to thank the participants for logging on, and I'd like to thank Bruce for a wonderful presentation to start us off. Today I'm going to talk about the research that we and others have done looking at the psychobiology of pain, fatigue, and exercise in CFS, ME, and fibromyalgia. So for today's presentation, I'm going to begin looking at some of the acute exercise research in chronic fatigue syndrome and fibromyalgia, looking at cardiovascular and perceptual responses during exercise, and then talk about some of the methodological considerations, and then give a couple examples of some studies that are more recent. I'm then going to switch gears and talk about some of the consequences of exercise, particularly post-exertional malaise research in chronic fatigue syndrome and fibromyalgia, briefly talking about the definition and characterization of post-exertional malaise, talking about some of the previous research, transitioning into some of the more current investigations where I think there's been some exciting research conducted, and talk more about methodological considerations. And then I would like to just briefly talk about acute versus chronic exercise, and how try to just address the question, and certainly not answer it yet because we haven't addressed it in the research, of how it is that acute exercise can worsen symptoms for CFS, ME participants, patients, and fibromyalgia patients, yet the literature suggests that chronic exercise can be helpful, at least for a subset of patients. So when we look at previous investigations looking at cardiovascular responses to exercise, a number, in fact the majority, have reported abnormal cardiorespiratory responses. And these have been characterized by reduced exercise capacities, this meaning low oxygen capacity, so a low aerobic capacity, metabolic abnormalities in the forms of oxygen delivery, carbon dioxide production, lactate production, impaired blood flow to the active musculature, which will also limit the amount of oxygen that's delivered to tissue, which is our energy source, low sympathetic drive, although some have reported high sympathetic drive. And in particular, Inbar in 2001 speculated that chronotropic incompetence, or a slow acceleration of the heart, could lead to inadequate oxygen delivery to muscle, leading to early muscle fatigue. Now, one of the limitations of all of this research is that we're not sure how any of this cardiovascular and muscular fatigue research translates to the feelings that, of fatigue that CFS patients experience. On the perceptual side, there's been quite a bit of research that has reported an abnormal sense of effort in chronic fatigue syndrome, meaning how hard they perceive exercise is. In fact, Lowry in 1997 speculated that chronic fatigue syndrome could be best described as a dysregulation or disturbance of effort sense. As an example, if a CFS patient, if it was harder to do everything every hour of the day, every day of the week, every week of the month, and every month of the year, you could understand why they would experience debilitating fatigue. Now, our lab has taken a little bit of a different approach when it comes to the abnormal sense of effort. I don't think that it should be described as an abnormal sense. It's actually an accurate sense of effort. It just happens to be exacerbated in some cases, and I'll talk about that in a moment, and that this accurate sense of effort is actually a really good tool to use to determine what types of exercise and how intense it should be for an individual to perform. When, as an example of some of the previous investigations, DeBecker and colleagues in 2000 published a paper with a very large sample, the largest sample that I've seen in an exercise study of CFS patients and controls, 427 patients and 204 controls, and they performed graded cycle ergometry. That's a maximal exercise test. The CFS patients began at 10 watts and increased at 10 watts every minute until they had to stop. Controls, on the other hand, started at 40 watts and increased at 30 watts every 3 minutes. So we have two different exercise tests, and this is the first problematic part of this study, is that they're comparing the cardiovascular responses of these patients and controls, yet they're doing two different exercise tests, so that's a limitation. They define maximal effort as a respiratory quotient, that's the relationship between oxygen and carbon dioxide, of greater than 1, and a heart rate of greater than 85% of their age-predicted max, which is 220 minus your age. Again, these aren't standard criteria for a max, so this is another limitation of this otherwise very large and well-conducted study. And what they found was that CFS patients had significantly reduced peak heart rate, VO2, which is oxygen consumption, and watts, which is power output, compared to control, suggesting that they had an abnormal cardiorespiratory response. Now, our reading in the literature has really pointed out a lot of limitations of previous research. And one I just mentioned, non-standardized exercise testing procedures. So if you do two different exercise tests in patients and controls, it's very difficult to compare them statistically because you're really comparing apples to oranges in terms of how the cardiovascular system responds. Another is the use of physically active control groups. Most of the studies use physically active controls, and if you're going to determine whether or not someone has low aerobic capacity, you should at least control for how physically active your control group is, or else you're basically going to find differences in fitness based on differences in physical activity. Looking at the perceptual responses in previous research of acute exercise, there's really been a non-standardized assessment of perceived exertion. Oftentimes they're measuring fatigue and not exertion, which, although they are related constructs, they are independent. And oftentimes people look at RPE only at peak. And if you look at peak exertion and you're giving a maximal exercise test, everybody should stop at the same point. And then finally, a major limitation of previous research is a failure to account for comorbid illnesses that might occur with chronic fatigue syndrome, in particular fibromyalgia. And so this really left us with the question, when we look at cardiovascular responses during an acute exercise bout, are we looking at a phenomenon of CFS, a pathophysiological phenomenon of the disease, or are we really looking at an epiphenomenon of testing individuals with very low physical activities and low fitness? So in order to address that question, we published a paper in 2006 looking at the influence of aerobic fitness and fibromyalgia on cardiovascular or cardiorespiratory responses and perceptual responses to exercise in patients with chronic fatigue syndrome. So the purpose, as I just stated, was to determine the cardiorespiratory and perceptual responses to exercise in CFS while using standardized exercise testing procedures according to the American College of Sports Medicine guidelines, by accounting for comorbid fibromyalgia by looking at patients with chronic fatigue syndrome who did not have comorbid FM and those who did, and controlling for aerobic fitness, which I'll describe in a moment. So for our methods, we tested 29 participants with CFS only, and by CFS only I mean they did not have comorbid fibromyalgia. We didn't assess them for every other comorbidity they might have. We also had 23 who had chronic fatigue syndrome and a concurrent diagnosis of fibromyalgia, and 32 sedentary controls, so those who did not report exercising more than 1 day per week. For our experimental procedures, we had both patients and controls perform the same maximal cycle ergometry test, increasing at 5 watts per minute every 20 seconds until volitional exhaustion. We measured perceived exertion using a 6 to 20 perceived exertion scale, and we measured leg muscle pain during exercise using a 0 to 10 scale, and then we measured the cardiorespiratory responses using a metabolic cart. We restricted all of our analyses to only those who could complete a maximal exercise test according to American College of Sports Medicine guidelines. And I will say that 93% of our participants could complete a maximal exercise test. We then did our analyses on the entire sample, regardless of their fitness level, and then we found 18 participants in each of the 3 groups for a total of 54 who were matched within 1 milliliter per kilogram oxygen consumption. So they were matched very tightly on their fitness. So here are the results. On the left here for pain and perceived exertion during exercise, we have the results for the entire sample here and here, and the results for the matched sample. So if we looked at the entire sample for pain and perceived exertion, we found that the CFS plus FM participants reported more pain than both CFS patients and controls. So here we have pain intensity as a function of their percentage of peak oxygen consumption. The CFS patients are the closed squares, the controls are the triangles, and the CFS patients with comorbid fibromyalgia are the circles, and they had greater pain throughout the exercise test compared to both the other groups. We also found that the CFS and CFS plus FM patients had elevated perceived exertion, found the exercise to be harder compared to controls. However, when we matched on fitness, we found that only the CFS plus FM participants had greater pain and greater perceived exertion, and that the CFS only patients had the same exertion and pain responses, statistically at least, as our sedentary controls. When we look at the heart rate responses, for the entire sample again, CFS in the squares, CFS plus FM in the circles, and the controls in the triangles, we found that the CFS plus FM patients had a slower accelerating heart rate and that and a lower ventilatory response to maximal exercise compared to the sedentary controls. So at first glance, this would appear to be consistent with previous research looking at abnormal cardiorespiratory responses. However, when we looked at our participants who were matched on aerobic fitness, all of these differences went away. There were no differences in the heart rates or ventilation or blood pressures or carbon dioxide productions or end-tidal CO2s between any of our 3 groups. So from this, we concluded that comorbid fibromyalgia can really affect the perceptual responses to exercise in terms of pain and perceived exertion, that neither diagnosis really appeared to affect the cardiorespiratory or metabolic responses to a single bout of exercise, that the previous research, the equivocal findings, are likely due to a failure to control for differences in aerobic capacity and a failure to account for comorbid illnesses, particularly fibromyalgia, and that pain during exercise might be an important consideration for exercise prescription, determining how much a patient can perform and for how long. Now, I emphasize that was to a single maximal exercise bout, and Van Ness and colleagues in 2007 from the University of Pacific published a very interesting study where they looked at the metabolic responses to consecutive exercise tests in chronic fatigue syndrome patients and controls. So they had them come in, do a maximal exercise test on a bicycle, then 24 hours later had them come back and do that same maximal exercise test again. They measured their peak aerobic fitness, the VO2 peak here. They measured their anaerobic threshold, which is the point where oxygen and carbon dioxide diverge from one another. They look at the percent heart rate achieved and the duration in minutes. In test 1, CFS patients and controls, they looked very similar, which would be very consistent with our previous research, showing a lack of differences in their metabolic responses to exercise. However, when they conducted the second test, they found that the controls could match very well what they had done in the previous test. However, the chronic fatigue syndrome patients had a very low, a significantly lower peak aerobic capacity and a lower anaerobic threshold, suggesting that now they are showing a metabolic abnormality and could not mount the same exercise test 2 days in a row. This study motivated us to go back and look at our submaximal exercise data that we had conducted a week or two following our maximal exercise test. And we did this by modeling the psychological response to submaximal exercise in chronic fatigue syndrome and fibromyalgia. So we had participants exercise for 20 minutes at 40% of their peak VO2. So this is a pretty low exercise intensity. And then we measured their intensity and perceived exertion responses over this 20-minute period and then during a 3-minute recovery. And what we can see here, during sustained exercise at a relatively stable power output or a stable work rate, we found that the CFS patients and the CFS plus FM patients rated exercise as more painful in their leg muscles and as requiring a greater amount of effort throughout the exercise task compared to our sedentary controls. We also looked at blood pressure and stroke volume responses. So here we have systolic blood pressure in millimeters mercury, averaged across each 4-minute bout during the 20 minutes of exercise and recovery, and then stroke volume at baseline, and then throughout exercise, and then recovery again. And what we found was a very different response between our CFS plus FM patients and our CFS only patients. For CFS only and controls, they had a typical increase in blood pressure during exercise that came back during recovery. However, the CFS plus FM patients did not mount any systolic blood pressure response to exercise, which is an odd response. And this is averaged over each of these 4 minutes, so this is not due to outliers. This is a failure of the systolic blood pressure response to respond. However, when we looked at stroke volume, here the CFS are in the black bars, the controls are in the green bars, the CFS plus FM in the red bars had double the stroke volume response compared to CFS patients and controls. So we have a failure of the systolic blood pressure response, greater pain intensity, greater perceived exertion, and a doubling of the stroke index response to the same relative exercise stimulus. So 2 things that we learned from this. One, that sustained exercise shows us something different than a maximal exercise test, and that we should really account for comorbid illness, in this case in our studies, comorbid fibromyalgia, because it does appear to be a different response between CFS only and CFS plus FM. So the take-home messages from those from the science that I just showed you were: 1, CFS and FM patients appear to have a normal cardiovascular response to short duration and high-intensity exercise. Having both CFS and FM makes exercise harder and more painful, and this may seem like a duh to patients, but we were really surprised that the CFS-only patients didn't have an abnormal response in terms of their pain, given that one of the criteria is musculoskeletal aches and pains. A sustained exercise may be a different story than maximal exercise, and it really deserves further research attention. And then finally, the model of using repeat exercise bouts to uncover potential cardiovascular abnormalities shows promise and also deserves further research attention. So I'd like now to switch over to the second topic, and that's looking at post-exertional malaise, or the consequences of acute exercise in chronic fatigue syndrome and fibromyalgia. And so post-exertional malaise, if you look at the research case definition by Fukuda, it's defined as extreme, prolonged exhaustion and sickness following physical and mental activity, and it must last more than 24 hours. If we look at the clinical case definition by Carruthers and colleagues, it's defined as debilitating malaise and or fatigue, generalized pain, deterioration of cognitive functions, and worsening of other symptoms occurring either immediately or a delayed period of time following physical or mental exertion. And it's accompanied by a lack of endurance for patients and rapid muscle fatigue. If you look at personal testimonies, you get even greater context to the kind of the consequences of being physically active. One participant described to us a need to stop grocery shopping, very similar to Bruce's example, mid-shop, stow the shopping cart, lay down in their car for a half an hour, and then return to finish shopping. Others have reported they were completely unable to perform activities of daily living, so a huge interference in their lives. And others have reported a debilitating crash following even minimal exertion that can take weeks to recover from. And so the context and the degree of post-exertional malaise is not captured very well at all by the research case definition, and it's captured a little bit better, but not entirely by the clinical case definition. When you look at previous investigations of post-exertional malaise, the vast majority have taken a immune system etiology approach. And so it's worth talking a little bit about immune system research. For one, when we look at immune system, pro-inflammatory cytokines, other immune function, and markers of oxidative stress at rest, we really find mixed findings in the literature. And this has been reviewed nicely by Nadelson et al. And Klimas and Kanuru in 2007. But the one consistent finding has been a decrease in NK cell function, in particular natural killer cell cytotoxicity, suggesting that there's an impaired immune response in chronic fatigue syndrome. And I would also point out the recent examination of cytokine networks appears very promising. And I'm referring to Gordon Broderick's work, and he works with the Nancy Klimas's group, where they've looked at the relationship between cytokines within a network approach using very complex and telling statistical models, where they look at how cytokines speak to one another and the degree and strength of relationships between different cytokine networks. And they found very interesting differences between CFS patients and healthy controls. When we look at the exercise studies, we also find mixed findings as regards to immune system function pre and post-exercise. But I will point out that the more recent studies have been much more consistent. And I think this is due to the technology and the look at and looking at more of a systems-oriented approach. When we look at symptom flares post-exercise, here we see a lot of consistency in the research. Patients following an acute bout of exercise will report increased feelings of fatigue, cognition, muscle and joint pain, weakness, headaches, nausea, lightheadedness, and a host of other symptoms. Other research has shown a decrease in physical activity following a maximal exercise test compared to their pre-exercise levels of physical activity. Others have shown that maximal exercise alters the circadian rhythms of patients. Research in both CFS and fibromyalgia have shown that acute exercise alters the pain modulation capacity of the patient, and this is done in a bad way, that they actually decrease the amount that they can modulate their pain. There's been some research suggesting that there's no influence on sleep architecture, and a little bit of research showing that acute exercise, at least a single bout, doesn't have influence on simple cognitive function, although the patient reports of cognitive fog following exercise are pretty widespread. So I'm going to give you a couple examples of studies that were done looking at certain aspects of post-exertional malaise. We recently published a study in the Journal of Pain in 2010 looking at pain sensitivity pre and post-exercise in Gulf War veterans with muscle pain, with chronic muscle pain and fatigue. What we did here was we looked at the pain, their sensitivity to heat and pressure pain prior to and following a submaximal exercise test at 70% of their peak aerobic capacity. So this is moderately to hard exercise, and we had them conduct this for 30 minutes. So here we have their responses to different temperatures that were delivered for 8 seconds apiece at 44, 45, 46, all the way to 50 degrees Celsius, 50 degrees Celsius being a very hot temperature. And then we looked at their pain responses from 0 to 20 in terms of how intense it was and how intolerable it was, or the affective response. The black bars here are the Gulf War veterans with chronic muscle pain pre-exercise, while the white bars are them post-exercise. Healthy Gulf veterans pre are in red, and healthy Gulf veterans post are in green. The first thing that you should notice is that for every temperature, the Gulf War veterans with chronic pain and fatigue report each one of these temperatures to be significantly more intense and more unpleasant or intolerable. And the second thing that I want to point out is that following submaximal exercise, the white bars, the Gulf veterans with chronic muscle pain had increased pain sensitivity and increased intolerable ratings compared to their pre-exercise ratings. This means that the Gulf War veterans with chronic muscle pain and fatigue became more sensitive to painful stimuli following exercise. And this is opposite of what you would normally see in a healthy population. They would actually become less sensitive. This suggests that the central nervous systems of Gulf veterans with chronic pain and fatigue, and perhaps patients with CFS and fibromyalgia, are compromised and are unable to modulate pain effectively. Perhaps the most exciting research to come out of late has been that by Alan Light and his colleagues at the University of Utah, where they were starting to look at potential mechanisms of post-exertion malaise. And they did this through looking at white messenger RNA on white blood cells. And so they published this in the Journal of Pain in 2009. They looked at baseline, mid-exercise, a half-hour post, and 8, 24, and 48 hours post-exercise participants' mental fatigue, physical fatigue, and pain, and found that, first of all, patients, of course, are reporting much more mental and physical fatigue and higher pain at baseline, but it's also increasing from 8 to 48 hours post-exercise. So consistent with a post-exertional malaise response. They also looked at messenger RNA for pro-inflammatory cytokines, and they found that compared to the controls up here on the top, baseline, 30, 8 hours, 24, and 48 hours post-exercise, the CFS patients and those with CFS plus FM had significant increase in the anti-inflammatory cytokine interleukin 10 and toll-like receptor 4. So they had increases in cytokine responses where the controls did not. But I think most exciting was this very novel finding that the participants with chronic fatigue syndrome had increases in the receptors on their white blood cells for acid-sensing ion channels, the A63 here, purogenic receptors, 2x4 and 2x5, those are ATP receptors, and a trend for the vanilloid receptor 1. All of these receptors have been implicated in sensory pain processing. And so an upregulation of these sensory pain processing receptors could be one potential mechanism why patients feel post-exertional malaise, particularly an increase in pain following an acute bout of exercise. Light and colleagues have even gone as far to say that these might be fatigue receptors as well. So an increase in messenger RNA for these fatigue receptors on white blood cells could be an indication that there's a heightened ability or a heightened signal being sent to the brain concerning fatigue. They followed up this study, Andrea White, in 2010 in the Journal of Pain, so this is the same participants as the slides I just showed you before, looking at symptom flare post-exercise. And what they did, they took a unique subgroup approach to this. So when they looked closer at their data, they found that they had certain CFS patients who had a high symptom flare, shown here in the black and white striped bars, and CFS patients who had a low symptom flare, who had in these gray and white striped bars, and then the controls are in the black bars. So when they looked at their physical fatigue, mental fatigue, and pain compared to baseline, they found that this subgroup with high symptom flare were the only ones that had increases in physical fatigue, mental fatigue, and pain. And the patients with low symptom flare looked a lot like controls. When they looked at their cytokine responses, they found something very interesting. It was only those who had high symptom flares who showed an exaggerated cytokine response post-exercise, particularly in terms of IL-10, IL-6, and IL-1 beta. So this suggests that the pro-inflammatory cytokines are actually linked to the symptom flare that's associated post-exercise. A very exciting finding in the literature. So to follow up that, the CFIDS Association has funded myself and, as Kim mentioned, Sanjay Shukla at the Marshfield Clinics to perform a metagenomic study of chronic fatigue syndrome and post-exertional malaise to look a little closer at potential mechanisms of why patients feel more sick following the acute bout of exercise. For this study, and it's ongoing right now, the first objective is to determine whether the intestinal microbiota in patients with CFS harbor an altered community of microbes compared to normal, healthy control subjects. So does their gut microbiota, their commensal and pathogenic bacteria in their gut differ from control subjects? And then we're going to take it one step further to determine if translocation of these bad bacteria from the gut into the circulatory or lymph system is enhanced after maximal exercise, giving us one potential mechanism why patients might feel more fatigue. I'll also report that we're going to collaborate with Alan Like and his group and look at some of those messenger RNA responses and look at the relationship between increases in messenger RNA and our gut microbiotic findings. So from the post-exertional malaise, some take-home points for everyone. CFS patients report a variety of symptom exacerbations following acute exercise. The mechanisms that underlie a worsening of illness in CFS-ME are unknown, but I think the recent data is very encouraging, implicating pro-inflammatory cytokines, implicating messenger RNA for sensory receptors. However, I think it's also likely that there are multiple mechanisms at work here. So in addition to the immune system, there's probably the hypothalamic pituitary adrenal axis or neuroendocrine system, our work looking at gut bacteria, and certainly the central nervous system, the brain as well probably plays a significant role. I would also point out that the intensity and duration necessary for illness exacerbation really requires close study. So how much is too much in a patient is something that we really need to research. And I think this is going to vary from individual to individual, but I think that it will give us a handle on how much we can use, how much a patient can do and get benefits from exercise, and also help us to determine if everyone should be exercising or if there's only a subgroup that should benefit from exercise. And then obviously, as I just referred a moment ago, the brain mechanisms of post-exertional malaise would be a very interesting area of research that we're pursuing in our lab right now. So I'd like to end the presentation with just a discussion. Our laboratory is very interested in looking at. So the question is, or the facts are that acute exercise is consistently associated with exacerbation of symptoms in both chronic fatigue syndrome patients and those with fibromyalgia. However, there's limited evidence in chronic fatigue syndrome that suggests that chronic exercise training is beneficial. In fact, a recent study suggests there are benefits to adolescents with CFS as well. There's actually strong evidence in fibromyalgia that chronic exercise training is beneficial. So how is it that an acute exercise bout that is so noxious and so illness exacerbating can become a chronic treatment? And we're really interested in looking at the time course of these changes. Is it that there's a subgroup of patients that can get through the post-exertional malaise and then start to adapt to training and become a chronic treatment? Or is it that only those patients who don't get post-exertional malaise are the ones that benefit? I will say that we have some recent data that I'm going to show you here that isn't published yet, that physical activity does appear to be protective, but this has not been systematically studied yet. And so what we've done in our lab is we measure physical activity in all of our patients prior to doing brain scans for all of the tasks that we do. And what we've looked at is that our physical activity levels related to brain responses to pain in patients with fibromyalgia, some of who have comorbid chronic fatigue syndrome. And what we found was that physical activity levels are positively associated with brain activities involved in regions involved in pain modulation, and negatively associated with brain activity in regions involved in pain encoding. So these orange areas on the brains here are classic areas, the dorsolateral prefrontal cortex and the posterior insula. They're involved in our descending inhibition of pain. So they help us regulate the amount of pain we receive. This blue spot is the sensory cortex. That's involved in encoding the sensory discriminative aspects of pain, or how intense it feels. So what we found was that the more physically active a patient reported being, the greater they were able to modulate their pain, and the less activity they had in their sensory regions of the brain. We looked even closer at this. We gave them 5 stimuli in a row in the magnet and had them rate each painful stimulus on their hand. And those who had the greatest amount of physical activity had an actual decrease in the amount of pain to each consecutive stimulus. And that relationship is shown here. Those who had the lowest physical activity had roughly no change in their pain intensity ratings across the 5 stimuli. So this indicates to us from an association, this is just a correlation, that physical activity, maintaining physical activity, however the patient can do it, can have important physiological benefits. And so the last thing I'm going to talk about is a study that we haven't even started yet, which is, yeah, Kim?
Can you just quickly explain what you mean by chronic exercise versus acute exercise? I've had a few people ask that.
Sure. So when we talk about acute exercise, and I apologize for that, when I'm talking about acute exercise, I'm talking about 1, 2, maybe 3 bouts of exercise. When I'm talking about chronic exercise, this is when you're doing 1, 2, or 3 bouts of exercise for several weeks in a row. And so you're maintaining an exercise training regimen. You're becoming more physically active on a daily basis. I hope that helps.
And can you substitute the word activity for exercise, or is this specific exercise like we think of it in the Nike commercials, or for people with CFS and
we don't know the answer to that
okay.
yet. And so that is exactly leads in very nicely to this study that we're looking at, which is the impact of exercise on pain sensitivity, brain function, and quality of life, which is not in this title, in Gulf veterans with chronic pain and fatigue. And so very briefly, the last thing I want to do is kind of, this is how we're thinking about doing exercise training trials. The main thing that we want to do, and I know this is very busy, just follow my pointer here. This is one group of individuals coming in as group 1, and we're going to have them perform 16 weeks of exercise training that's tailored to each individual's capacity. We're then going to follow them up at 6 and 12 months to see how they're doing. And each week that they come in for training, we're going to measure their clinical symptoms. And then at week 6, 11, and 17, we're going to bring them in and actually do brain imaging responses to painful stimuli to look at their brain function. And we're also going to do a technique called diffusion sensor imaging. We're going to look at their white matter tracks to see if we can change the connections between pain modulatory regions. We're going to perform pain psychophysics to look at their pain sensitivity. But really importantly, we're going to measure physical activity outside of the exercise training, bouts. One of the things that we're really interested in is that the patients that volunteer for these exercise training studies, they might do nothing else. They might actually have a decrease in their total physical activity for the rest of the week. And so we want to see whether or not that's true, and whether or not there are subgroups of patients who can maintain their physical activity levels or those who actually have an increase. And so the 3 main things that we want to do with this is, 1, we want to determine, is exercise training beneficial for patients with chronic pain and fatigue? For whom it's beneficial for? Are there subgroups that don't benefit from exercise training? And finally, we're going to begin to ask why exercise might or might not be beneficial. To start to do mechanistic studies, we really need to understand the whys in order to tailor our exercise and to make it more specific and effective treatment for those it works for. So I'd like to acknowledge all the generous funding that we've received in our laboratory from the National Institutes of Health, University of Wisconsin, CFIDS, who's hosting this webinar, and the Department of Veterans Affairs. And I thank everybody for their attention. I have no idea how far I went over. I apologize if I went way over.
Well, I wasn't keeping time either, but I know we had a lot of questions come in during your presentation, so it obviously sparked a lot of interest among the participants. So I'm going to give you a bit of a rest. I'm going to ask, make sure that Bruce turns his speaker or his unmutes himself. Bruce, are you back with us?
Myself.
Okay,
yes,
great.
Just unmuted myself.
Good, great. Thank you. And I'm going to send the first question over to you. And let me just say that one of the reasons that we paired these 2 speakers and these 2 very different looks at the phenomenon of post-exertion relapse, post-exertional malaise together is that often when we have material about one or the other, the practical versus the biological, we get questions about the other end. So we thought pairing them together would be a good sort of comprehensive look at both what happens experientially and what's going on inside the body that might explain this very challenging characteristic feature of CFS. So with that sort of in mind, I'd like to ask Bruce if you would just sort of take what you heard Dane talk about, and I know the literature you're very familiar with, and maybe try to put that in terms of how people can manage their expectations about activity, and maybe just revisit the topic of that sort of service charge on energy levels that makes it more difficult for CFS patients to overexert themselves, and the payback being greater than it would be for an otherwise healthy person.
Okay. One of the big messages that I heard in Dane's presentation that applies to how people live their day-to-day life is that CFS manifests itself in a wide range of severities. So I agree with him completely that with what he was talking about at the end of his presentation on the importance of tailoring your activity level and other parts of your life to your specific set of circumstances, so that the answer for me is not necessarily the answer for somebody else, etc.
Okay, and going along with that, the research examples that Dane provided are all based on sort of in-laboratory exercise stressors that can be measured, and then you can strap a heart rate monitor on, and measurement of exercise capacity in very specific objective ways. But how do you translate that when you talk to individuals about kind of everyday life things? Many people said, oh, I can't exercise. Getting to the doctor, or you know, sitting at the table for dinner with my family is a physical stressor in the same way that Dr. Cook talked about an exercise bike bout of exercise. What can you say about that, Bruce? Hello? Did we lose Bruce? Oh, goodness. Well, Dane, are you on?
I'm here.
Okay, maybe you can address that in terms of, you said we really don't know as far as kind of activities of daily living. It's not as easy to measure those in a lab situation, so you kind of set up this construct of an exercise challenge.
Correct.
How can people sort of equate that in their everyday life? Because you're certainly not talking about training for, you know, a 5K or doing kind of that hit the gym sort of exercise. You're really talking about
this
the
is
exertion.
A great challenge. I think it's a huge challenge from both the patient perspective, because you're asking them to add in a physical stressor that could potentially make them more sick, and according to the responses, almost invariably makes them more sick. And I don't know how to answer them from a clinical perspective, because I just don't know enough about the clinical experience of patients to be able to give an educated recommendation. But I can say from a research perspective that what we are going to try to do is try to determine, at least in groups of participants, how much is too much at a group and individual level, that we can at least give some generalizable knowledge that patients can use to help, at least as a starting guide of, you know, if we find that, you know, if you're at if you exercise for, let's say, more than 25 minutes, the majority of patients experience post-exertional malaise. And so we can give them, I think research can give guidelines, but it certainly can't inform an individual about what's right for them.
Do you know if there's been any research, there are a few questions, about exercise that's done in water, like water aerobics or gentle movement that happens in a swimming pool versus you trying to use a recumbent bicycle or something else that
Right.
It doesn't have the same properties as a water-based activity?
Yeah, they've done those primarily in fibromyalgia exercise training studies, so people who come in and do water aerobics a couple times a week. The rationale behind it is that the impact of aerobic exercise outside of the water, there has been some hypotheses that the muscles of patients with fibromyalgia are more susceptible to injury, and that you can limit that by using a nice fluid liquid like water, so that it minimizes the speed at which the joints move, and it certainly minimizes impact of that. And so they think that one way that it can decrease post-exertion malaise is by decreasing the amount of muscle damage and pain that's experienced during the exercise. Does that answer the question?
Sorry, I had my mute button on. I've got.
Okay.
Sorry about that.
Does that help?
I think it does. And I was just going to point out that the word exercise is, of course, a very charged word, and you're quite familiar with that. And we published last month an article by Jenny Spatilla titled "The E Word," because the word exercise does have such tension associated with it, if you will.
Let me take a moment to address that, just from a definition standpoint. Yeah, we use, as exercise scientists, it's almost like we don't even notice that we're saying exercise. But there is an important difference between exercise and physical activity that you alluded to in your earlier comment to me, Kim. Exercise is a structured bout that's within a time frame that's at a particular intensity. I think from a patient perspective, what's important is to maintain your physical activity levels and try to avoid becoming disabled. So physical activity can be any number of things that you do, walking to the mailbox and your grocery shopping and your planning for holidays, and all of those things require physical effort, and they are a physical activity. And so they're less structured, but they're no less important when it comes to the health and well-being of individuals, including those with chronic fatigue syndrome and fibromyalgia.
And this topic of the physical activity side of things also came up in the webinar that we had with Dr. Peter Rowe, who is an expert on autonomic symptoms, postural orthostatic tachycardia syndrome, and
Sure.
all forms of autonomic dysfunction. And he made the point that it's also important to the circulatory system in the way that not only the muscles work, but the vasculature works to pump your blood around and lymph fluids around the body, to make sure that those, down to that fine level of tissue, doesn't become deconditioned as well, because that can contribute to worsening symptoms or continued poor physical function. So kind of have to think of it on all of those terms. Bruce, are you back with us?
I am.
Good, good, good. I'm sorry that found out from one of my staff members that you'd gotten your computer shut down on you, and you were absent for a few minutes there while you got back up. So we're glad you're back. And I
am too.
Kim, did you want to transfer controls to you?
Yeah, that would be great.
Sorry about that.
So let me just get mine back. Bruce, I'm going to shoot a question over to you. Going back to where we started the program with, how can individuals learn kind of the warning signs about where that point comes where they need to make a decision about taking a rest or taking a break from their present activity, so that they don't go into that deficit period and then have the much more extended payback that often follows?
Okay. One of the big problems with addressing the issue you just raised is that the effects of exertion are often delayed, so that by the time you receive some signals from your body that you're feeling really, really tired, you may have already gone outside of your energy envelope or gone outside of your limits. It's certainly good once you have recognized the fact that you're outside your limits to stop as quickly as you can. But I think the long-term solution is what I was saying earlier before my computer went kablooey on me, and that is by keeping records, you can identify over time what your limits are. And I know I did that myself for exercise of the type that I think that Dane was talking about. I was trying to determine how much exercise I could do safely. So I would walk, say, for 20 minutes one day, and for 25 minutes another day, and for 30 minutes another day, and then observe what happened not only while I was exercising, but more importantly, a couple of hours later, and sometimes even the next day. And by having records of how much exercise I'd done and what the effects were, I could then figure out what my limit was. Even if I couldn't know it at the time I was doing the exercise, by checking the amount of exercise I'd had and the intensification of symptoms that occurred either later that day or the next day, I could then determine what my exercise limits were. So I think the long-term answer to that is keeping records, which shouldn't be burdensome, shouldn't take more than 2 to 4 minutes a day, but which pays great dividends.
And when you say exercise, do you include in that kind of the regular activities of daily living, of you know, making meals and tending to family members and, you know, taking care of sort of all the routine things? That has to be factored in as well, isn't that true?
Absolutely. And also going back to the slides about different types of activities that affect your symptom level, that it also means keeping records about stress, and you may identify, for example, not only that some circumstances intensify your symptoms, but some individual people may intensify your symptoms. So the record keeping is very, very broad in terms of trying to identify physical activity, mental activity, social activity, sensory, emotions, and stress, all those different categories, and how they affect your symptoms.
You know, one person sent a comment in that they've sort of figured out how to cut back the Christmas card list and put up minimal decorations and limit the number of social interactions, but the most draining part of the holiday season is trying to explain to people who aren't terribly receptive to understand why you know, there are fewer interactions and somebody's not taking part in all the things they're invited to and that kind of thing.
That's always a big challenge.
I'm looking here for another. You had a slide about self-talk and expectations, and several people, both in the questions we got beforehand and during the program, have said, how do you retrain yourself to not accept, or to accept the fact that you can't do as many things as you'd like to do, and if you're a type A personality, what are the first steps toward letting go of some of the self-expectations?
That's really a big one. I think at base, a lot of that is coming to terms with loss, which is a process that typically takes several years. But the losses that come through chronic fatigue syndrome can be very great. Obviously, loss of health, often loss of income, loss of friends, sometimes loss of family, loss of job, so that you lose a lot of your sense of identity. So a lot of the work involved in this is kind of psychological work in coming to terms with the fact that your life isn't now what you thought it would be at this point. And there are some resources on our website dealing with that. The other thing that comes to mind related to self-talk is that self-talk is often hard to identify when you're first working at changing it, but it pays big dividends if you'll stick with it. And I'd recommend as a starting point, if people want to go there, an article on our website titled Taming Stressful Thoughts, and that will give you an outline of the 3 steps you have to go through to change your self-talk. There are many, many books, several of which are mentioned in that article, that people can use all to train themselves in cognitive therapy, or they can get help from a therapist who specializes in that area. But I'd say that's an area of change, that namely changing self-talk, that takes some work but pays big dividends.
And I've also heard through the years that while this can be cyclical, in other words, as you move through your life and your circumstances change and evolve, and you go from parenting to grandparenting or whatever the life change is, that you may need to sort of revisit this topic at different periods in your life. Absolutely true.
Yep. It's because the theme of loss doesn't go away, but you may, as you're implying, people may experience it over and over again particularly as they get to marker events in their life. Other people are having kids, but I can't have kids. Other people are moving ahead in their career, but I'm stuck at home, et cetera, et cetera. So it's loss is something that people have to come to terms with, as you're suggesting, multiple times during their lives.
Okay. Dane, I'm going to kick back to you for a minute here and ask you a question about whether you think, based on the research that you've done and the literature that you're very familiar with, whether you see the post-exertional relapse as a required symptom to define CFS in sort of contrast to other conditions, or whether you think that it should continue to be sort of one of the optional symptoms under the research definition.
Given the prevalence of post-exertion malaise, I think that it would be helpful if it was a requirement, because I think it would decrease a little bit further the heterogeneity that we see in chronic fatigue syndrome, in terms of who, from a research standpoint, who gets accepted into studies, and it doesn't stop you from having a diagnosis of chronic fatigue, but perhaps chronic fatigue syndrome or CFS ME should have a post-exertional malaise component. So I think I would be supportive of that.
And that's that topic has come into sharp relief in particularly the different studies and the different results coming from the XMRV studies, and I think it's kind of put case selection and the research definition versus clinical definitions really into a new light, and hopefully we'll be making some progress in terms of those issues in the near future as it becomes clearer how important the case definition and the selection of patients for studies is to the outcomes.
Yeah, and I think if I could add, I mean, in a best case scenario, you wouldn't so much have to exclude and include so strictly as if we got large enough samples and we could start to really answer the questions rather than excluding people who don't fit a particular model of a not well understood disease. But if we could get certainly the funding and then the sample sizes to look at these subgroups of patients and start to look at the group that experiences post-exertional malaise and compare them to the group that does not, similar to the White study that I went over, and find some amazing differences that are very informative in terms of understanding disease pathophysiology.
Yeah, I think the power of these studies in terms of the size and the number of subjects and the heterogeneity or the variability of symptom patterns within the group studied has really deserved more attention than it's gotten. And
absolutely,
as you suggest, it's often a limitation of the funding sources as to how big these studies can be, and then what information we can draw from each one and then generalize to a broader population. So, hopefully we're moving in a productive direction on all of those topics. We have exceeded our time, and I know that there are still many questions that people have raised, and hopefully a lot of them have been answered in the two very informative presentations that we've had today, as well as the Q&A session. Bruce, I'm gonna ask one last question of you, and then make some concluding comments, and then we will wrap it up. But a couple people have asked how long it takes for pacing to be effective, and how long how soon people can expect to start feeling positive effects if they are attentive to the pacing issues, and maybe that will leave people with some hope.
Okay. I would say that people who take our class often feel an immediate effect by using that preemptive rest that I described in my talk. I think if I were to make one suggestion where you're likely to have a demonstrable impact and to have it quickly, it would be by taking several brief rests a day, and there's lots of information on our website about preemptive rest. You can look in the pacing area. In terms of applying pacing more broadly, I think it's very definitely a long-term effort, so that at least when I was trying to recover, I tried to look at it in terms of saying, if I've gained 5% more control over my life than I had a few months ago, that's great. I've got the momentum on my side. So I tried to make comparisons that focused on I'm making progress rather than on, my goodness, there's still a tremendous gap between where I am today and where I was before I got CFS. So I think going back to the theme of self-talk, it's important to be able to focus on your triumphs and say, I can expand my triumphs, rather than doing the comparisons of I can't do everything a healthy person can do. If I could make one final comment, Kim,
Please do.
A number of the questions that came in during the registration period talked about the dilemma of I want to have holidays like I used to have, but I pay a big price for that, and sometimes I feel compelled just to go ahead and do it, to kind of revive the sense of what it was like previously. And one of the themes that we have in our program is to try to think of multiple alternatives. So rather than thinking either I can't do the holidays or I have to do everything the way they used to be, to think of it in terms of the spectrum, and to find a place somewhere on the spectrum that gives you some gain without all of the pain. And I think the example I gave from Rose during the talk is a good one in that regard, that she cut back on the amount of time that she spent with her daughter and granddaughter during the time that they were with her when they were house guests. So she didn't get everything she wanted on that side, but on the other hand, if she had just 2 days to recover rather than 4, 5, or 6 months, she gained a tremendous amount on the other end. So that was how she resolved that particular dilemma for herself, to balance the good thing about the visit versus the avoidance of a terrible price.
And I think that's good food for thought to close with, both as we kind of think ahead and look ahead to the upcoming holiday period, and also year-round, because unfortunately these difficult, challenging choices occur all through the year and not just here in the winter months. So before I close, I just want to remind folks we have the last webinar of our 2000 series coming up on December 2nd, and kind of continuing in the spirit of the season, we have Dr. Gail Aronson from the University of Miami sharing with us some observations and research and thoughts about spirituality and health, and how spirituality can often be an important adjunct to maintaining quality of life. And we will be having some new webinars in 2011. We have not yet put a schedule out for those, but we'll do so in the coming weeks and be building on that schedule. So keep an eye out in CFIDS link and our website and Facebook page and all the places that you can find information from us about these things. I've provided some of the URLs here, and I've sent a couple out through the chat box for things that have come up in the topic. We'll also send out a follow-up email to all the registrants for the program with these links and others that were mentioned today, so that you have those resources at close hand. And then finally, just to remind folks, we know we get people who aren't familiar with the CFIDS Association of America of our mission for CFS to be widely understood, diagnosable, curable, and preventable. And this is the sort of year-end giving season. We have our annual fund underway, and if these webinars and the other services and research projects that we support are important to you, we encourage you to support that with a gift of any size. We are grateful for all the forms of support that we get, and really do need that support to continue bringing these services and programs to you, and to sustain the important research like that going on at University of Wisconsin and other centers. The LIGHTS research was also funded by the association, so we need you to help us sustain those efforts. Bruce, Dane, thank you so much for sharing your experience, your training, and your insights into this really challenging topic of post-exertional relapse and malaise with our audience today. I think it's been informative. Some folks have said it was fantastic to have both ends of that spectrum available in the same program, and others feel a little overwhelmed by that, and trying to absorb all the great information on such a wide range of topics. But we will have the recording posted and the slides available, so hopefully revisiting it over time will bring home all the valuable points that you both made. Thanks so much.
Thanks for having me.
Thank you, Kim.
Well, this was great, and we appreciate the audience hanging in well past our scheduled end time and the time that our presenters gave to preparing for and delivering our program today. And we wish everybody a good afternoon and a safe and hopefully minimalized crash over the Thanksgiving holiday. Best wishes to everyone and their families as we enter this holiday season. Many thanks, and have a good day. Bye-bye.